Hi everyone, my name is Eden, and recently I've searched about digital signature, and I think it's a very important topic to know and understand. That's why I thought about this video to explain what is digital signature and how it works. So when you want to send a message from one place to another, you want to verify that the receiver got your message without any changes. That means that there weren't any forgery and tampering in the sending and receiving process. That's why digital signatures are so important, because they're a mathematical way of verifying the authenticity of digital messages. The digital signatures are based on asymmetric cryptography. This process protects sensitive information with two mathematically linked keys, a public key and a private key. A private key is only known to the person it belongs to, and a public key is shared with anyone who needs access to the digital message. Every sender and receiver has their own private and public key, and we trust both sides that the private key has not been shared with anyone else. So encrypting and decrypting signature-related data relies on both the sender and receiver's respective private and public keys. Bob wants to send Alice a message, and he wants to make sure that Alice got his message and not from anyone else. When Bob creates his digital signature, he takes his plain text message and passes it through a hash function, and then he encrypts it with his private key. That is a digital signature. He takes the digital signature with a plain text message and his public key and sends it to Alice. In this case, we don't mind if anyone else has Bob's public key and they can read Bob's message. We only want to be sure that Alice got Bob's message and not anyone's else. Now Alice got Bob's message, a plain text message, a digital signature, and Bob's public key. Alice takes the digital signature and decrypts it with Bob's public key. And then she takes the plain text message and passes it through a hash function. If both of the values are the same, that means that the message is truly from Bob. If they weren't the same, that means that the message has been forged by an attacker. Now this is a small example about all the digital signature that we just talked about. So I have here a folder with two files, a hash program.c, it's in a C language, and I have a message.txt. In the message.txt we have a small text that I have to pay someone $300. Now if I want to take the text message and run it through the hash program file, I have to compile the hash program to run it. So I'm going to take the hash program.c, and I'm going to compile it and call it hash. As you can see in the folder behind the terminal, I have here a new file called hash. And if I'm going to write cat hash, I'm going to see lots of gibberish that we don't understand. Now if I want to take the message and run it through the hash, so this is a response when I take the message.txt and run it through the hash program. So now I'm going to generate myself a private and public key by the RSA algorithm. This algorithm will generate a public and a private key that are mathematically linked to each other. That means that every private key has its own public key. So as you can see here, I generate my private key. And if I'm going to see what I have in my private key, it's a long 2048 bit. Now through the private key, I'm going to generate my public key. Public keys can be used to encrypt data, and only the matching private key can use to decrypt it. So now I'm going to generate my public key through my private key. Now you can see if I'm going to see what I have in the public key, it will be a shorter string than the private key, and this private key I can broadcast it to others, and the private key is going to be saved for myself. So as I explained before, when I take a message and run it through the hash, I want to take the same hash compiled message and encrypt it with my private key. And afterwards, the answer of the encryption, I want to be in the file called, a new file called signature. So you can see behind the terminal, I have a new file called signature. And if I'm going to write cat signature to see what's inside, I'll see lots of gibberish. So now we know that the message was hashed and encrypted in the signature file. So the next and the last thing we want to do is create a tar file and send it to the receiver that we want to send it to. So we're going to write a tar. We'll call it message.tar. And the files that we're going to put in is the hash file, so that he can hash his message through my hash program. I'm going to send my message.txt, my public key, and my signature that I've just made. So you can see in the folder for the file behind the terminal, I have a new message.tar, and that is the message that I want to send to my receiver. So for now, for this little example or demo, I'm gonna make a new folder called inbox, and I'm gonna send or copy my message.tar to the new folder inbox. So it's gonna be like the folder inbox is the receiver that got my message. So now I'm going to go inside the cd.index. So I'm just in the folder behind me. I'm going to go inside the folder too. And I want to extract my message.tar. So I'm going to write tar -xif, and I'm going to extract that message. And you'll see in the folder behind me, I have all the files that I've just sent to the receiver. So now I have all the files that the sender has sent to me. I have the message.txt if I want to see what's inside of cat message.txt, and this is what he sent to me. Now the second thing that I want to do is take the signature that the sender has sent to me and decrypt it with a public key that he sent to me, and then I'll see what I have inside. As you can see, I've got a number, and the third thing that I have to do is take the message.txt that I got and run it through the compiled hash that the sender has sent to me, and I'll see I have the same values. That means that the message.txt is truly came from the sender that sent me the mail. Now let's open the message.txt and let's change it a little bit. Let's write, instead of I will give you $300, we'll change it to you will give me $300. Let's save it and open again the terminal. Now once again, I'm going to run the message.txt through the compiled hash program. And this is the answer that I got from the message.txt, hashing the message.txt. And once again, let's decrypt the signature as before with the public key and the signature that the sender has sent to the receiver. And we'll see that the values aren't the same. That means that the message isn't trustable and the message hasn't been received from the sender. Now if I go back to the message.txt and I'm gonna go back to how it was before, and just gonna leave a small enter and save it and run the message.txt and through the hash, I'll see I'll have a different number. And if I'll go back to how it was at the beginning and run it again, I'll have a different number. What I want to explain here, that every enter or every space is a character that affects the compiled hash with message. One more important thing that I'm going to add is why don't we encrypt all the message and just send it like that? It's because when you encrypt a message, you have an amount of length that you can encrypt. So if you have a large text file, you cannot encrypt all of it. So that's why it has to go through a hash function, and then the hash function, it's very small, it's a shorter string, and that's a string that you can encrypt and send it to the receiver. Thank you guys so much, and I hope you understood. Have a great day.